Every one of us, knowingly or unknowingly, takes chance every day. Chance is an essential part of our life and we cannot escape from it. It enters into our lives in thousands of ways. The importance of probability theory in our life can be judged from the fact that it deals with uncertainties which we come across quite often in our lives. It is a step towards the direction of measurement, which has been one of the main objectives of science. Probability is a measure of chance. The history of probability can be traced back to the first half of the 17th century when the first attacks were made on the problem of chance. It originated as a mathematical tool. A group of gamblers, unable to answer their own questions about the fall of dice and other gambling problems, went to some of the leading scientists of the day. Among others, they approached the great Italian mathematician Galileo. Galileo found these gambling problems worth careful studies. Not only did he solve them all, but went on to write a short treatise on the game of dice. The science had thus begun its study of chance, which continued to the present day and led to results that even Galileo could have not foreseen. It became a branch of science rather than gambling. Not many years later, history repeated itself, this time in France. Among the gamblers of the period, there was one Chevalier de Marais, whose devotion to gambling was tempered by a scientific curiosity and insight which enabled him to formulate some very interesting problems. He approached Blaise Pascal, a friend of his, with very perplexing questions. Pascal was a strange blend of mathematical genius. In his early days, mathematics reigned undisputed. His invention of the adding machine at the age of 18 is but one of a series of accomplishments that made him a reputed mathematician. Pascal solved many of the Mere's problems and was able to distill from them the basic ideas of probability. With the name of Pascal, that of P format can also be associated in finding the new theories of probability. Format was a lawyer by profession, and he never devoted himself wholly to mathematics. Still, his contributions to this field ranked him as one of the great men in this field. Pascal and Fermat corresponded with each other and gave rise to many basic laws of probability. Like many new branches of knowledge, the theory of probability also rose rapidly. After about half a century of the work of Pascal and Fermat, the first systematic treatise on probability came due to James Bernoulli, which was published posthumously by his nephew Ian Bernoulli in 1713. James Bernoulli was followed by a great name in the history of science, that of Laplace. Laplace lived through the stormy period of French Revolution, and in addition to his scientific contribution, he served in various administrative capacities. He did extensive research spread over a number of years in probability theory and finally published a book on it. The next great name in the theory of probability is of the German mathematician Gauss. He was one of the versatile mathematical genius that ever lived. In his admirable book, Men of Mathematics, E.T. Bell ranks Gauss with Archimedes and Newton as one of the three mathematicians of all time. Gauss undertook the theory of measurements, which can be approved by use of the idea of chance. He evolved the famous law now known as Gauss' law of errors. It is believed that a French mathematician, A.D. Moivre, who spent 66 years of his life in England, was the first to evolve the law of errors. But it did not come to light as he did not get it published. Since the time of Gauss, the theory of probability has been developed and expanded by a host of workers who have made full use of immense resources of mathematics of past century. The outstanding contributors to the modern probability theory are Levy, Mises, Fisher, Chebyshev, Kolmogorov, Lyapunov, Markov, and many others. Had the gamblers kept their difficulties with themselves and not brought it to the notice of the mathematicians of their period, the theory of probability perhaps would have not been developed as a well-organized member of the mathematical family. The emergence of probability theory as a systematic, organized branch of mathematics has facilitated the study of many complex situations. Today, the success of probability has spread over almost every field of human endeavor. One of the most potent and fruitful applications of the theory of probability is in the field of statistics. Not only this, it has become fundamental to physicists, biologists, economists, psychologists, industrialists, businessmen, and philosophers. It is becoming increasingly apparent that many principles of theoretical science have their explanations in the laws of probability. The theory of probability has penetrated and illuminated an extraordinarily wide group of subjects. Emile Borel of the French Academy of Sciences, who has edited a comprehensive series of books, has this to say. It is thanks to the theory of probability that modern physicists explain the most hidden properties of energy and matter, that biologists succeed in penetrating the laws of heredity, thus permitting agriculturists to improve the stock of their animals and plants, in insurance and in forecasts of every variety. The theory of probability is constantly used. It is of interest not only to card and dice players, who were its godfathers, but to all men of action, heads of industries, or heads of armies, whose success depends upon decisions, which in turn depends upon two sorts of factors: the one known or calculable, the other uncertain and problematical. Thank you.